Alright, you need to be able to solve all types of equations. I'm going to split this up into two videos. The first video will be on linear equations with fractions, quadratics both with factoring and quadratic formula, an easy type of cubic equations, square root equations, and absolute value equations. Here is a linear equation with fractions in it. We'll notice that they're both being divided by 4. There's a few ways to do this. You could turn this into a fraction and combine like terms by turning this into fourths. But when I see fractions, the easiest thing to do to get rid of them is to multiply both sides of the equation by the least common denominator. And the least common denominator in this case is 4. So what I'm going to do is I'm just going to multiply both sides of the equation by 4. The left side is a binomial, so the whole side gets multiplied by 4. The right side is a single term. On the left side, 4 times negative 2b is negative 8b. Now this is the point of multiplying by 4. When we distribute to this one, multiplying by 4 and dividing by 4 are inverses and cancel out. And so what happens is we get 15b. Here, multiplying by 4 and dividing by 4 cancel out. And so now we have an equation that doesn't involve any fractions at all. We can add these together and divide by 7. So pretty straightforward Algebra 1 type of equation. All right, let's look at this next one. This is a quadratic equation. And if there's only one variable, like if it was 8n squared equals, I don't know, 16 or something, when there's only one variable, you can solve for n and get n by itself. So n squared equals 2, divide both sides by 8, and then n equals plus or minus the square root of 2. Remember, when you take the square root on both sides, it's plus or minus. So that works if there's only one variable, but if there's an n squared and an n, that won't work. And if this is the case, then what we will always do is make the whole thing equal to 0. So we'll move everything to one side. So we will add 320 to both sides to make it equal to 0. And from here, we have two options. Make sure you don't lose your equals 0. I see kids do that sometimes. We could either use the quadratic formula or we could factor. In either case, it will be much easier if we factor out the common factor first. It looks like 8 goes into all of these. I know 8 goes into 32. I know 8 goes into 8. Let's see over here. Does 8 go into 104? 8 goes into 10 once. And 8 goes into 24 3 times. So, because 8 goes into all of these, we know from factoring that we always want to factor out the common factor. So it's 8 times n squared, 8 times 13n, 8 times 40. And if you're not 100% sure what's going on here, you should go rewatch the factoring mastery video. This is a trinomial. It can be factored into n and n, and we need two numbers that multiply to make 40 and add to be 13. That's 5 and 8. It's still equal to 0. And since we were able to factor it, factoring is the easy way, because when things multiply to make 0, there's only one way for that to happen. One of the factors, here there are 3 factors, 8, n plus 5, and n plus 8. One of these 3 factors needs to be equal to 0. Well, 8 never equals 0, so that's not possible. N plus 5 could equal 0 if n is negative 5, and n plus 8 could equal 0 if n is negative 8. These are the values of n that will make the factor 0, which means the whole thing will equal 0. And so these are the solutions. This is a cubic equation, although it's a pretty easy version of a cubic. You'll notice that even though there's a cubic, we can factor out an x because they have a common factor. So it's x times x squared plus 4x minus 19 equals 0. And I'd like to find two numbers that multiply to make negative 19 that add to be 4. But 19 is prime. Only 19 times 1 gives you 19. And those don't add to 4. So this is not factorable. Okay? So we're in this situation where either this factor could equal 0 or this factor could equal 0. Well, this factor will equal 0 when, so let me highlight the two factors. X is one factor. This is the other factor. This is fully factored. X could equal 0. The other option is that this could equal 0. Well, how do we figure out where that is? We can use the quadratic formula. And if you don't know it, you do need to memorize it. This is one of the things you need memorized from Algebra 2. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. We learned a song, negative b plus or minus the square root of b squared minus 4ac all over 2a, if that helps you remember. And these are the solutions to when we have a quadratic. These are the x values when a quadratic is equal to 0. It has to be equal to 0, and we want this to equal 0. And so here is a is 1, b is 4, c is negative 19. So I'm going to plug that in over here. It's negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times a times c all over 2a. 2 times 1 is 2. This can be simplified, and I'll do that over here. Negative 4 plus or minus the square root of, here we've got a negative times a negative, which is a positive. So we end up with 76 plus 16, which is 92. We can't divide inside of a square root, and we can't divide only one of these things because there's a binomial. The 2 is dividing both. So what we need to first do is simplify the square root of 92. Square root of 92 breaks up into square root of 4 times square root of 23. And the square root of 4 is 2. What we're looking for when we simplify square roots is what is a square number that we can do the square root of that multiplies to make it. So 4, 9, 25, something like that. And so this simplifies to 2 times the square root of 23. So this whole thing is equal to negative 4 plus or minus square root of 92 is 2 square root of 23, all divided by 2. And now we have a binomial where we can divide both terms by 2, and so we do that. So this is negative 2 plus or minus the square root of 23. We don't need to write 1 times the square root of 23 because 1 times anything is itself. So x is 0, or negative 2 plus or minus the square root of 23. Those are the 3 solutions. All right, square root equations. The first step is to get the square root by itself. The next step is to square both sides. Notice here that when we square both sides, the left side is a single term, but the right side is a binomial. So we need to put that parentheses and make sure to square the binomial correctly. When we square, the square root and the squared cancel out. When we square a binomial, we have a shortcut for this. You square the first one, multiply these two together and double it, and then square the last one. What is not good is if you just put, if you try to distribute something like this, this is very bad. Okay. This is now a quadratic, so we make it equal to 0. So we're going to subtract 2v. Negative 4v minus 2v is negative 6v. And we're going to add 5, sorry. 4 plus 5 is 9. And we can factor this. This is v minus 3 times v minus 3, or v minus 3 squared. There's a single solution here. V equals 3. Now, we do need to check our answers in a square root equation because there could be extraneous solutions. So when we plug in v, we're seeing does it make the equation true. We get negative 3. I'm just plugging in 3 here to see what works, whether it works. Plus the square root of 6 minus 5, does that equal negative 2? 6 minus 5 is 1, square root of 1 is 1, negative 3 plus 1 is negative 2, and so this does work, and so it is our solution. All right, absolute value equations. In absolute value equations, the first step is to get the absolute value by itself. So we're going to subtract 4 on both sides to get the absolute value by itself. And then remember what absolute value does. It turns whatever's inside of it positive. So this is going to get turned positive no matter what. So whether this thing on the inside is a 71 or a negative 71, the absolute value will make it positive 71. And so there are 2 possibilities. The thing on the inside could equal 71, or the thing on the inside could equal negative 71. Either way, we'll end up with a positive 71 here. From here, it's just linear. We add 1 to both sides, and we can do the same thing on this one. We'll add 1 to both sides, and then we divide by negative 7. So This is negative 72 over 7, and this one is a equals 10. So our two solutions are a equals, I'll write it like this, negative 72 sevenths and 10. All right. So that is step 1 of solving all equations, part 1 of solving all equations. There'll be another part with the other types.